The next question of CodeChef starters 120 is find permutation. So basically, in this question, we are given a array A. So in the array A, we have 1 to n integers exactly twice. Right? So we are basically given an array which has 1 to n integers exactly twice. So because 1 to n integers are present exactly size, so obviously the length of the array should be 2 into n. Right? So the length of the array is 2 into n, and there will be there will be every integer from 1 to n exactly twice. Now we need to find a permutation p. Let's say p0, p1, p2, so on till pn minus 1, or let's consider it as one based only as per the question. So it's p1, p2, p3, so on till pn. So let's say we found a permutation p. Now in the array A, we know that every number has two occurrences, right? So element 1 has two occurrences, and let the index of the first occurrence be L1, and the next second occurrence be R1. So let these indices be let L1 be the occurrence of the first number. Let L1 be the index of the occurrence of first number 1, which has smaller index, and let this be the occurrence of 1 which has the larger index in it. Now similarly for 2 2 occurs at index L2 and R3. 3 occurs at index L3 and R3. So on till element n occurs at index Ln and Rn, right? So these are the ranges. I mean, not ranges. These are the points where the smallest indexed occurrence of 1 occurs, and this is the index where the largest indexed 1 occurs for 1. Similarly holds for all. For 2, this is the smallest indexed occurrence of 2's index, and this is the largest occurrence of 2's index, right? And so on. Now we need to find a permutation such that for a fixed pi, basically for any pi, after removing all of these, pi plus 1, pi plus 2, so on till pn. So basically for a fixed pi, remove all the elements j such that j is greater than I and less than or equal to n. Remove all these. So after removing all these elements from A, basically by remove, it means considering this element, remove both the occurrences of this element in A without changing order of any other element. Similarly, remove this elements, both of its occurrences from A without changing the order of the elements. So until remove this element's occurrence, both the occurrences in A without changing the order. Now after removing all these elements, now consider Pi's occurrences, Pi's both the occurrences. So first occurrence is at index L of Pi, and the next occurrence is at index R of Pi, right? So let's not consider the original indexes. Now after removing, basically we remove both the occurrences of Pi plus 1 from A, then both the occurrences of Pi plus 2 from A, so on till both the occurrences of Pn from A. After removing that, let A dash be the new array. Now in the new array, let's say L of P1 is the smallest indexed occurrence of P1, and R of P1 be the largest index of the occurrence of Pi in the new array A dash form. Now, between these two elements, basically between L of Pi to R of Pi, all the elements that are present should be at most length of A dash by 2. And we know that always length of A dash will be a even number because each time we remove two occurrences. And initially the length of A was an even number, which is 2 into. So now at most, so basically in between L of Pi to R of Pi, number of elements that are present should be less than or equal to length of A dash, which is the new array after removal, by 2. Right? So this is what should hold. So for a fixed I, this is what should hold. Similarly, for considering any I from range 1 to n, this should hold. Right? So as a just basically consider any I in the range 1 to n for a fixed Pi after removing all j's in the range j greater than I less than or equal to n after removing all the occurrences of pj after removing both the occurrences of pj in the range in this range in the new array a dash the elements between the first the smallest in the elements between the first occurrence of pi which has the smallest index and the elements between the basically the elements between the first occurrence of pi which has the smallest index to the element which has the largest index should be at most length of a dash by 2, right? So we should find such a permutation which will satisfy this condition, right, for the given initial a. So permutation, so basically here permutation means elements from 1 to n should appear exactly once. So we should print any permutation which satisfies. There can be multiple also, sometimes which will satisfy the given conditions. If such case occurs, we can print any of them. And it is guaranteed that always such a permutation exists. So there won't be an invalid case. Always such a permutation exists. Exists, right? So let's go with the constraints. Constraints of the problem. So constraints are test cases can be in the range 1 to 10 power 5. N can be in the range 1 to 3 into 10 power 5. And AI can be in the range 1 to n. And here it is guaranteed that every number in AI from 1 to n appears exactly twice. Right? And it's also guaranteed that summation of n over all test cases won't exceed 3 into 10 power 5 in the first place. Uh, like uh, the the test cases are given in such a way that summation of n won't exceed 3 into 10 power 5 in any of the cases. So let's see how we can solve this problem. So let's see how we can solve. Basically, to solve this, firstly, let's consider the array as A1, A2, so on till A of 2n minus 1. Right? Now, let us start constructing the permutation in reverse, right? Because yeah, now let's say this is our permutation and we don't know like what should we consider. So firstly, let's decide what should be the last value. We know that last value will be something which is already satisfying the conditions, right? Because if we consider this index, there is no other index towards the left which we can remove, right? So that is why on the original array, let's find out which value can be kept here. Which value can be kept here. Once we find that out, then we can just remove that. And for this index, we can find out same thing now holds, right? That is after removing this, we'll get a new array a dash. Now in a dash, we know that we should remove one number which satisfies the conditions which were mentioned, right? Why? Because now in a dash we already removed this. So now let's find out which will actually satisfy that and just put that over here and so on. So let's construct it like this in the reverse fashion. Why? Because last number only depends on the whole array. Last second number will depend on something, will depend on some array which is a dash after removing the last element and so on, right? So now to find out which element will actually like which element can be kept at each iteration, we can do the following. That is, firstly, let's make one observation to find out which element to be kept. So here, basically, the observation is for that, let's take a as 5, sorry, n as 5, and then construct any. The claim is always when we move from right to left and pick the first element, which is the left occurrence of some number, basically, which is the first occurrence with the smaller index of some number. Move from right to left and find out the first occurrence with smaller index of a number. So basically, uh, we are finding out a number. We are just coming from right to left and finding out a number whose first occurrence with smaller index, like which is the first occurrence with smaller index. Like we are moving from left to right, finding out the finding out a number which is the first occurrence with smaller index for that number. So basically, what do this mean is, let's say we have a permutation like this, right? So what we do, we are moving from right to left. This is the second occurrence of number 2, right? With basically the index of this is larger. So let's call the smaller index occurrence as the first occurrence and larger index occurrence as the second occurrence for ease understanding. So this is the second occurrence, so we skip it. So here also we can replace it with finding out the first occurrence of any number. Right? So we are moving from right to left. This is the second occurrence, so we skip it. This is the second occurrence, we skip it. This is the second occurrence, we skip it. This is the first occurrence, right? Of 2. So we consider this. So we'll always keep putting 2. We'll always keep putting the first occurrence from right to left with the maximum index. So now in the permutation, we can put 2 over here at the end. So once this is done, we can just erase this. Now similarly, we'll do the same thing. Moving from right, this is the first second occurrence of any number. So we put 3. Now we remove these. Now this is the first second occurrence. This is the this is the first occurrence of any number, which is 1. So basically, this permutation will satisfy the criteria required for this A array, right? So now let us prove why always picking such left index is sufficient. So if we consider any array, so for now, let us just take A as n as 5. Then we can observe that because there are 5 numbers, in the worst case, what can happen is we want the first left index, right? Basically, we want the first occurrence of any number. So in the worst case, all these can be filled with last occurrences. Basically, all these can be filled with second occurrences of the numbers, and then this number will be the first occurrence of some number. So in the worst case, this can be the first occurrence and this can be the last occurrence of that number. But still, if we observe, number of elements between it is still lesser than or equal to mod A by 2, right? Which is 5 here. So it is still lesser than or equal to 5. So because of this, now after that, what we are doing is we are just erasing these two numbers. Now when we erase these two, again it became the same problem, but with a smaller length array. So in the worst case here also we can have all second occurrences, and this can be the first occurrence of some number, right? So this will be the worst case. So some average or best case, we can find the first occurrence somewhere over here only. And obviously second occurrence should be after it only, right? Because second occurrences index will always be larger. That's how we are doing. So if it's always greater, for sure number of elements between first and second will be lesser than or equal to mod A by 2, right? It will satisfy the equality that number of elements between the occurrences is less than or equal to mod A by 2. Now, because in the worst case itself, by doing this, in the worst case itself, we could get number of elements between both the occurrences as lesser than or equal to mod A by 2. We can just keep doing this process because of that. Now, the thing is, we can't do this process in a brute force way. That is, firstly finding the first left occurrence and then removing that, then again finding the left occurrence and so on. Because there are n elements, and if we do this process can take n iterations per element, right? Like to find out one particular element, we need n iteration. If we perform the process in a brute force way, it becomes n square, right? So to optimize this, what we can do is we can just take the permutation. So let us for now pick one A, 1, 3. So firstly, let's see what are we going to do, and then let's see how we can optimally do that. Five, four, right? So now in the permutation, we need to fill 5 of them. So here, if we see, this is our A. So from left to right, if we see, the first occurrence of any number that we got is 5. So we can put 5 over here and remove this. Right? Now the array becomes like this. Now the first occurrence that we got is 4. So we can put 4 over here and then remove this. And then the first occurrence of any number that we got is 3. So we can put 3 and then remove this. Yeah, one more small issue. So let 2 be present over here. Like we didn't consider the second. Yeah. So now let's say the array is like this. So now every number appears twice. Previously we didn't consider one more. Now let's see how will the answer vary. So firstly, we'll find from right to left, we'll find the first occurrence of any number. So 2 is the first occurrence of 2. So we put 2 here and then we can remove this. From the above observation and the proof, we are doing this process. So we are again finding out the first occurrence of any number and that is 5 here. We can put 5. Now again find out the first occurrence and it is 4. And now again find out the first occurrence of any number. So 3 is the first occurrence. So basically we are treating first occurrence as the occurrence of a number with smaller index and second occurrence as the occurrence of the number with larger index. So that is why this is the first occurrence. 3. Then we'll find the next first occurrence, which is 1 here. So this will be our permutation. Right? So now if yeah, let's go back to the original array. So for this 2, 5, 4, 3, 1. Right? So this is the permutation for this array. Now you guys can check whether this permutation satisfies the conditions or not. And as per what we observed and what we proved, this should satisfy. Right? Now, if we now we just saw if we repeat this process in a brute force way, it takes n square. To optimize it, we can just observe one thing. For each number, you can just calculate what is the first occurrence, where is the first occurrence of that number coming, right? So now let us do it in a efficient way. So to do it in an efficient way, let's calculate the first occurrence of a number. So the first occurrence of 1 is at position 0, considering 0 base. The first occurrence of 3 is, the first occurrence of 2 is at 9. First occurrence of, first occurrence of 2 is at, so let's index them, 9, right? So first occurrence of 2 is at 5. First occurrence of 3 is at 1. First occurrence of 4 is at 2. And first occurrence of 5 is at 3. So among all these, we can observe that to make it efficient, the first occurrence's order of any element doesn't change. So we remove some elements. Why? Because we are always picking an element from right to left. So though we remove some element, first occurrences of all these elements will still remain the same, right? Until they are removed. So that is why we can just sort them based on their first occurrences in reverse order. So 2, 3 is 1, 4 is next greater is 5, 5 is at 3, 4 is at 2, 3 is at 1, and 1 is at 0, right? So we sorted them based on their first occurrences in the reverse order. So now the permutation is, now the P is 1, 3, 4, 5, 2, right? So basically the first one should be kept at the last, next one should be kept at the last second, this one should be kept at the last third, this at the last second, this at the last fourth, this at the last fifth, right? So our permutation is 1, 3, 4, 5, 2. So when we did the brute force and verified it, we got the same permutation, right? So this is how we can just find out the first occurrence of any number from right to left and put it at the end of the permutation. Then the next one at the last second, and so on, right? So to do that efficiently, we just made an observation that as we are removing elements from right to left, always first occurrence of a number which is not removed will never change, right? Because it will never change, we can just uh, consider all the first occurrences, all the numbers and their first occurrences, and like we can consider all the numbers and their first occurrences as a pair, and then sort the numbers based on their first occurrences in reverse order. So once we sort it, put the we can just put the first one at the end of the permutation, next one at the last as the last second number, next one as the last third, and so on. So this way we can just construct a permutation. So this is one way to construct with the following observations. There can be multiple ways to construct it also. As multiple answers are, if there are multiple answers, we can print any. So this is one of the way to construct it with the above observations that we made. So if we look at the time complexity, it will be big of log n log n. It is big of n log n because we are sorting the elements based on their first value, right? And space complexity, we can say it is big of n as we put track of the first occurrence of every number. For that, we are assuming will be using a array of length n. So assuming we are using a array of length n, and even we need a array to store number and the paired left of I, and then sort them, right? Basically not left of I, the number and the paired first occurrence, that is the leftmost occurrence. So the size of that array can be n in the worst case. So we can say it is space complexity is big of n. This is per test case. So here, if we see n depends on the test cases, that is summation of n will be less than or equal to 3 into 10 power. So this is sufficient. This TL is sufficient enough to pass in the, this time complexity is sufficient enough to pass in the given TL. TL is 3 seconds. So it is sufficient enough to pass in 3 seconds. And big of n memory is sufficient enough, per test case is sufficient enough to pass for the given memory limit. So given memory limit is 1.5 GB, which is very large, very huge. So this space complexity is sufficient.